Consider the function y equals sine x over cos x. What we have here is a quotient, which is to say one quantity dividing another quantity. Now there is a rule for differentiating a quotient. What we can do first of all is we can change this into a product where the two quantities multiply. So instead of having a dividing cos x, we have a multiplying cos x to the power of minus 1. So dy by dx, remember the formula is u dash v plus uv dash. We differentiate the first, we leave the second, plus we leave the first and differentiate the second. Differentiating cos x to the power of minus 1, bring down the power, leave the contents of the bracket unchanged, reduce the power by 1 and multiply by the derivative of the bracket. So what we have then is cos x times 1 over cos x, those two will cancel. Then we have the two minuses cancelling. And we've got sine squared x times 1 over cos squared x. That should be a square. So that's 1 plus tan squared x. So what we want to do is to introduce the rule for differentiating a quotient, one quantity dividing another quantity. Differentiate the first, leave the second, minus, leave the first, differentiate the second, and divide by the second squared. So differentiate the first, that gives me cos of x, leave the second, now you'll notice that's cos x as well, 1 over cos x, minus, leave the first, and differentiate the second. So if we differentiate cos of x, remember, that's the important thing, v is cos of x, it's not 1 over cos of x. So v dash is minus sine x, and then we have v squared on the bottom. That's cos squared x on the bottom. So cos squared x plus sine squared x over cos squared x. And that gives us our 1 plus tan squared x. So here we have a first example then. We might want to list u and v. Sometimes that's useful, particularly when the functions are a bit more difficult. U dash is 3x squared and v dash is 3 times 2, that's 6x. dy by dx, the formula can be quite tricky to remember, so you differentiate the first, leave the second, then you subtract, leave the first, differentiate the second, and you divide by v squared, the second. So u dash is 3x squared times v minus x cubed times v dash, which is 6x. V squared is 3x squared plus 1 all squared. Now, we need to simplify this, so expanding on the top line gives us 9x to the power 4 plus 3x squared minus 6x to the power of 4. And that leaves us with 3x to the power of 4 over 3x squared plus 1 all squared. What we might do there is take out 3x squared as a common factor. That would give us x squared plus 1 over second example. So use 4 root x, which is to say 4x to the power of 1/2, and u dash is 4 times a half is 2x to the power of minus 1/2. We could always write that as 2 over the root of x. V equals x squared minus 2, and v dash equals 2x. So dy by dx, it's u dash, differentiate the first, leave the second, minus, leave the first, differentiate the second, over v squared. So what have we got then? We've got 2x to the minus 1/2 times x squared minus 2 minus u, which is 4x to the power of 1/2, times the derivative of v, which is 2x, all over v squared. So x squared take away 2 all squared. So multiplying out the brackets on the top line, we have 2x to the power of 3 over 2 minus 4x to the power of minus 1/2 minus 8x to the power of 3 over 2 . So that gives us minus 6x to the 3 over 2 minus 4x to the power of minus 1/2 over x squared minus 2 all squared. What I could do here is take out minus 2, x to the power of minus 1/2 from the top line, and that would give me 3x squared plus 2 on the top and x squared minus 2 all squared on the bottom. What I could do now is take this term down onto the bottom line. So minus 2 on the top over root x. It's as compact as it can get. So here's a question involving a quotient, but with an application. So let's proceed as normal. U equals x minus x squared. V equals 1 plus 8x squared. U dash is 1 minus 2x. V dash equals 16x. dy by dx, differentiate the first, leave the second, minus, leave the first, differentiate the second, over v squared. So 1 minus 2x times 1 plus 8x squared minus 16x times x minus x squared all over v squared. So that gives us, I'm going to have to expand the brackets, 1 plus 8x squared minus 2x minus 16x cubed minus 16x squared plus 16x cubed. We don't need to expand the brackets on the bottom line. Now we have these two terms cancelling out, which is fortunate. So 1 minus 2x minus 8x squared over 1 plus 8x squared all squared. So what we have now, here is our derived function. Now for stationary points, dy by dx equals 0, which tells us then that 1 minus 2x minus 8x squared equals 0. We're not interested in the bottom line equaling 0, that can't happen, the function is undefined. If the bottom line equals 0, this will factorise 1 and 1, 4x and 2x. We want a minus 2x, so there we have it. X then equals minus 1/2 and x equals 1/4. What we need now is the nature table. We know that dy by dx is 0 at minus 1/2 and 1/4. So what we could do is take the value 0 lying between minus 1/2 and 1/4, the value 1 and the value minus 1 to represent each of those three regions. Here is dy by dx here. So when x is 0, we have 1, which is positive. When x is 1, what do we have? We have 1 minus 2 minus 8, 1 minus 10 is minus 9, and it must be positive on the bottom line because we have a squared. So negative over positive is negative. When we take the value minus 1, so we've got 1 plus 2 minus 8, so that's negative as well. Now, decreasing, that's when dy by dx is less than 0. So the function is decreasing when x is less than minus 1/2 and when x is greater than 1/4, and it's increasing in this region here, which is to say between minus 1/2 and 1/4.